everyone and welcome. For the very first time, LG Energy Solution, this video's sponsor, let a creator into their battery manufacturing facility for a tour in Holland, Michigan. Lithium-ion batteries are currently transforming the automotive space. So in this video, we're going to be answering three main questions. What is a lithium-ion battery? How does it work? And how is it made? So a lithium-ion battery is made up of four major parts: cathode, anode, electrolyte, and separator. You can think of your cathode and anode as your positive and negative terminals of the battery, and you're going to be exchanging lithium back and forth as well as electrons between these two sides. Now you have an electrolyte solution which is facilitating that lithium exchange back and forth, and then you have a separator in the center which is preventing your cathode and anode from touching so you don't have a short circuit. Okay, so let's get a better understanding of these components, starting with the cathode. Whenever you hear about certain metals being used for battery chemistry, nickel, manganese, cobalt, aluminum, this is generally in reference to the cathode material. And generally speaking, these materials mean the cathode is the most expensive part of the battery, which is the most expensive part of an electric car. Now, there are all kinds of different chemistries which can be and which are used within the automotive industry, and you may hear car makers say things like NMC 622 when talking about the chemistry for their battery. This is discussing the composition of the cathode, in which it is roughly 60% nickel, 20% manganese, and 20% cobalt. Some interesting points here though: the industry is shifting towards chemistry with lower amounts of cobalt due to scarcity and sourcing, and higher amounts of nickel, which improves energy density but can reduce longevity. Now, we're probably getting too deep too quickly, but increasing the nickel content of the cathode is actually a really interesting discussion. Using higher percentages of nickel tends to cause micro-cracking of the cathode, as well as increasing reactivity with the electrolyte. But you can actually use higher concentrations of nickel by using a gradient in the cathode, with higher nickel concentration in the center and less at the exterior. This results in a particle that's less susceptible to microcracking and has less surface reactivity with the surrounding electrolyte. So you get improved energy density without the major drawbacks of using high nickel content. Okay, that's just one component. We also have the anode, which is typically made up of a graphite structure. This is great for storing and exchanging lithium, but there are materials that can store even more lithium, like silicon. Because of this, silicon is currently being used in anode chemistries, but it has its own challenges, as it tends to have significant expansion and contraction as the lithium moves to and from the anode. Next, we have the electrolyte, which is typically a liquid in traditional lithium-ion batteries. This electrolyte is what allows the lithium ions to flow throughout the battery. Electrolytes are made up of lithium salts, solvents, and additives, and you want something that allows for lithium ions to travel easily, that doesn't react with other materials within the battery, with a low freezing point and a high ignition point, so that it's suitable for all kinds of environments. Finally, we have the separator, which again prevents the positive side and the negative side from touching. This separator has micropores in it, which allow for lithium ions to flow between the anode and cathode. But interestingly, the pores aren't actually always open. If the battery starts to get too hot, the pores can close, protecting the battery from overheating. Okay, so how does it all work? Well, I've separated this drawing into two sections here. On the left side here, we have what is essentially a dead battery that is just starting to charge. And then on the right side here, we have a full battery which is just starting to discharge and power our electric car. So the process is pretty straightforward. We have a lithium atom which is within the anode structure, and it loses an electron to that anode structure, which then goes on to power our car. Well, since the lithium has lost an electron, it is now a lithium ion, and it travels through the separator to find a parking space within the cathode structure, where it is then rejoined with an electron, and once again you have that lithium atom. Now, for charging, the process is simply the opposite. So you have your lithium atom, it loses an electron to the surrounding structure. That lithium ion then travels across through the separator, through this electrolyte, where it then finds a parking spot within your anode's graphite structure, and it is then rejoined by an electron, and once again we have a happy, stable lithium atom. Now, with this explanation, we're looking at just a single layer of these materials, but of course if you look inside a battery, you'll see many of these layers, and they can be packaged into different forms, with the main ones being cylindrical, prismatic, and pouch style cells. So the battery sheet could be tightly wound into a cylinder or a prismatic hard shell, or you can stack layers of these sheets into a pouch. Cylindrical cells tend to be faster and easier to manufacture, bringing down cost. It's a similar story for prismatic cells, and you now have very flexible sizing, but unfortunately the hard exterior shell and the packaging also means that this has less energy density. Finally, you have pouch-style cells, which take longer to make, but can offer better energy and power density. LG Energy Solution makes different types of cells as well as different chemistries, simply depending on what their client prefers to use for their applications. Now, once you understand how a lithium-ion battery works, I think it helps answer two key questions that are commonly brought up. First off, how do charge cycles relate to longevity? So we often hear that the more charge cycles you have, from full battery down to low battery, back up to high battery, back down to low battery, well, this impacts a battery's performance over time, and it'll slowly lose that performance over time. Well, why is that? Well, again, keep in mind that you have this lithium shifting back and forth within that battery. So you have expansion and contraction in different parts of the battery. So you have to manage that expansion and contraction, which poses challenges to the internal structure in order to have longevity. The other question it helps answer: why do batteries charge really fast when the battery is low, but much more slowly as you approach 100% charge? So remember, you've got a lot of lithium ions and they're all trying to find a place to stay within the anode's structure. So I've heard the analogy of it being like a parking lot, and I really like that, because if you think about a wide open parking lot with no cars in it, it's easy to park a lot of cars very quickly in there because all the spots are available. Well, as you get down to fewer and fewer remaining spots, as this battery gets closer and closer to being fully charged, well, it takes you a while to find a parking spot, so it's a little bit slower to charge that last little bit. Moving on to our third question: how are lithium-ion batteries made? And while I witnessed the full process from mixing up a metal slurry all the way to a completed battery pack, there's an extraordinary number of steps from start to finish, including about 850 quality control checks along the way. So we're going to keep this fairly high level, breaking it down into four main sections. First is electrode manufacturing. Here, the cathode and anode slurries are created and mixed. These mixes are then coated and cooked onto the current collector, generally copper foil for the anode and an aluminum foil for the cathode. The rolls are then evenly flattened before being cut into battery-sized pieces. Next, we get to cell assembly, where the battery-sized pieces are laminated, adding the separator and stacked into the appropriate number of layers for an individual cell. Finally, the electrolyte is injected, which starts the process of bringing the battery to life. Next, we're at formation, where the batteries are charged and discharged, as well as an aging process that's applied to stabilize the cells. With this complete, any gases that have formed within the pouch are removed, and the cell is sealed, inspected, and sent off to the final step, the pack process. Here, individual cells are inserted into a module where they're wired and connected, and then multiple modules are added to a single pack housing. That pack housing includes all the other required parts like DC-DC converters, bus bars, fans, or cooling equipment, and then the final fasteners are torqued, sealing the pack. It then goes through final inspections and tests before being stacked on pallets and shipped off to the car manufacturer. Again, witnessing the full process took a few hours, traveling through multiple massive rooms in the LG Energy Solution Michigan 1 facility, which has a 5 gigawatt-hour capacity. That's the equivalent of 50,000 large 100 kilowatt-hour battery packs a year, or 100,000 smaller 50 kilowatt-hour packs. And they're currently building another facility next door, which is going to provide 25 gigawatt hours of output, with mass production expected to begin in 2025. If you're interested, yeah, they are actively hiring quite a few positions and will be for the foreseeable future in this space. Worth noting, they've been actively researching lithium-ion batteries since 1992, and with over 30 years in this space, they've accumulated over 27,000 battery-related patents. This will continue well into the future as they look into different materials, inevitably solid-state batteries, and chemistries that might not even rely on lithium. It was awesome to be able to see this in person, so a big thanks to LG Energy Solution for sponsoring the video, and thank you all so much for watching. If you have any questions or comments, feel free to leave them below.